We are going to stream search race. So search race is created by Elron. So it's a car racing game, and it's an optimization problem, not a typical bot programming problem. So we do not have any opponents in this. We just have to optimize our car. So let's get started. So let's see what happens. So we have an arena where there are a lot of checkpoints. So we start at 0 initially, and our aim is to go to 1 and then go to 2 and then come back to 0. So our aim is to do this very quickly. So our car should move really fast. So I'm just reading out the problem statement. So every checkpoint has a radius of what, 600, right? Yeah, 600 units. Not really. Yeah, checkpoints are circular with a radius of 600 units. So we just have to enter inside this radius with our car to cross the checkpoint. So let's try something simple. So we are given the position of our current car and the velocity. We are also given the angle of the car. We have to print XY thrust and the message. So what we'll do is we'll just print the next checkpoint's position. We have the position of the next checkpoint. Okay, we get it at the start. So let's store all the checkpoints. So I'll just zoom it so that you can see the code a little bit better. Okay, say you can store checkpoint X. So how many checkpoints can there be at most? Okay, let's have it as 10. If this doesn't work, we can increase. And just store this. So we have the position of all the checkpoints. So now we need to know the checkpoint where we need to go, right? So initially it is 0. So this means we need to go to this checkpoint index plus 1, right? So what we will do is we'll print the checkpoint index of checkpoint X of, so the index would be, we need the next checkpoint index, which is checkpoint index plus 1, right? And if I'm currently at checkpoint 2, then it should go back to 0. So what we'll do is we'll do a modulus checkpoints count. So now we have the checkpoint index, so just print the position of the next checkpoint. So we'll go at maximum speed. Just print high. Let's try this test. It looks like we are going too fast, so we are unable to turn properly. Let's reduce our speed to 50 and try this. I'm not sure what's happening, so let's just print our current position and checkpoint. Our car spoiled this arena. Checkpoint. This tire scratches are nice to see. So to see the logs, I don't think we can see the logs anywhere. So okay, we have to maximize the spot. I'll just refresh this page. Alright, so now we got the error stream. It should be useful to debug this. There are test 7. Let's go back to test 1. Okay, the zoom is really wrecking the website. So I need to zoom out to see the console logs. This is probably some bug. So initially I get 0 as the checkpoint index. So I should go towards this point, right? But I'm printing some random position here. So let's see what is happening. So I'll also print the checkpoint positions. The first turn I get all the checkpoint positions. Let's copy this somewhere. So these are the list of checkpoints. But there are only 3 checkpoints, right? Why am I getting 9 checkpoints here? So let's see what's coming in the input. Okay, so just prints the upcoming 9 checkpoints. So it doesn't give how many checkpoints are already there. So what we can do is so it's just repeating. So if you see 2757, so this checkpoint is repeating twice. So we are getting 9 checkpoints totally. So we will just print without the mod and see what happens. So when I get 0, I am supposed to print the next checkpoint, right, which is 33 58 28 38. That's what I'm printing until this point. Okay, it says this as the first checkpoint. This should be the first checkpoint, right? So okay, so we don't have to do a +1 also. The given checkpoint index is the next checkpoint. So let's remove this and just go to the checkpoint index. So we are getting the first checkpoint's position here. Yeah. So looks like we just have to complete 3 laps in minimum number of turns. So now we are doing the third lap. So once we finish the third lap, we are completed. We got a score. So we need to minimize the score. So currently it took 237 turns. So we got a score closer to 235. So suppose if I increase my speed to 100, so this should reduce my turns. Nice. So let's submit this. See where we end up. We got a score of 48,396. Let's play all test cases. Let's check our leaderboard. So our score should probably appear soon. We are at the bottom of the leaderboard. So yeah. So we'll learn a little bit about vector algebra for our next step. So suppose if my car is somewhere here. Suppose if I have my car here. So let's take this as my car position, center of the car. And my next checkpoint is somewhere here. The center of this is this. Let's call this A. Let's call this B. And now we need to go in this direction. So this is our target. But suppose our car has already gone through another checkpoint from here, then we would probably, and we came something like this. Suppose if our car came this way, then our velocity, current velocity should be this, pointing this way, right? This should be our velocity. So just erase this. So what we have is, we have a position and we have a velocity. So right now we are only using the position, so we just print the position of the checkpoint. So now we are going to use the velocity as well. So our intention is to get to B, but we are already moving towards this direction, which means we have to aim somewhere. So if we aim here, our resultant direction would be somewhere here. So as per vector algebra, we have a force acting this in this direction, and we have force acting towards this direction. So the resultant should be somewhere in the middle, right? So we shouldn't be going this way, we have to go this way. So what we have to do is, instead of going towards B, we have to aim here. So if we aim to go here, then the resultant vector would be sum of this two, and our resultant vector should be pointing this way, somewhat closer to this, right? So what we will do is, so we have two vectors, right, which is we have a vector called AB, which is what we need to achieve. So this is the sum of AB vector plus the vector that we need to find, right? So this vector is what we need to find. So now to find this, what we can do is, so our x would be AB minus AB. So we need to subtract the target point with our velocity vector. So that is the idea here. So what we'll do is, we'll subtract the checkpoint with the velocity, which is checkpoint minus Vx, and here we will do checkpoint minus Vy. And let's try to go at, okay, let's try this. Now it should be avoiding the longer route, so it should automatically turn properly. It should be a lot better. Now suppose if I submit this, now I should get a better score. This looks closer to the old score, right? Previously this was taking till 200 turns. Now it's better. I think this is the old score. Let's try to compute again. Oh no, I closed that. How do you freeze this screen? Yeah, so this is 48,337. So now if we safely, so if we aim, instead of aiming here, let's aim somewhere here, so that we go, our resultant vector should be something like this, which means we will be, instead of going, taking this path, we will be taking a path like this, just like this. So we are avoiding this much time. So what we will do is, this, we have a magic formula here, so try that. So what we will do is, instead of subtracting by velocity, we will subtract by 3 into velocity. It's somewhat better, right? So what, till 152 tons, let's increase our speed to 200 and see what happens. 200 is too bad, right? So we are going like crazily fast. We are unable to control our car at 200. So let's try 150. Yeah, so I did target minus 3vx 3vy. So let's see this replay. This looks really nice. He did this in 120 turns. I think this is test case 0 or test case 1, I'm not so sure. But this drag was amazing. So instead of turning this way, we are turning left. I'll reduce my speed a little bit. 150 is still bad, I think. Let's reduce the speed to 120. What speed do you use, JRK? 100 plus random thrust. We are not dragging much still. So we are supposed to turn a little bit earlier here. Let's try 2 velocity 2vx 2vy. We need to go a bit slower, I think. So we are still too fast. Let's try 90. So you see this tire scratches. So we are taking a very long path. We need to control the speed here, probably based on the angle. So what we can do is like say we can have a variable called speed, and if angle is okay, let's see what the angle is. angle is probably minus 360 to plus 360, right? It should be minus 180 to plus 180. No, it's 0 to 360. We have to convert it to minus 180 to 180, only then it will be useful. Or what we can do is, if the angle is say more than 90, or at the same time the angle is less than 270, this which means we need to turn a lot of angle. So in this case we'll go at 0 speed, otherwise go at 100 speed. So this will make us do a quick turn here. Instead of taking a long turn after reaching the checkpoint, it should help us take a quick turn. So let's see how this works, and we need to use this speed here. Yeah. Okay, so the first turn itself the angle is greater than 90. Is it the case? So what is the angle in the first turn? Angle is 161 at first turn. I think that's probably wrong in the turn 1, because you are already facing towards the next checkpoint, right? Illidon, I think you need to note this as a bug. So angle is wrong on first turn in such race. So we can have a turn to fix this. So every turn will increase the turn variable. So at turn 1 we can move a speed of, say, I think we can go at a speed of 200 at the first turn. If turn is 0, speed is 200. And if the angle is very large, go slow, apply brake, otherwise go at 100 speed. Okay, clearly the angle seems not to work. So at turn 1 we have moved towards this direction. Okay, this is facing angle of the car, so it's not really the angle to the next checkpoint. So we are not going to do anything with the facing angle, so this will probably not work. Some things they have changed from CSB. Instead of giving the angle to next checkpoint, they are giving the angle of the current part. I don't know how that is even useful at all. Okay, now that we have played around with angles and velocity, so let's try to simulate this, and it's time to get into, say, there are how many people, 54, right? We are at 54th rank, so let's try to get to top 30. So our plan is to predict the future and then make a decision based on that. So the idea is, so when we are driving a car, we know where we will end up, right? So right now the problem is going too fast, and once we reach one, we are taking a longer path to two. So instead of that, if we have planned this earlier, we could have taken a shorter path like this, so going for a longer path. So we'll try to simulate this. So I need my source code, which is default code I use for any bot programming challenge, which is right here. This is starter code that I use for any challenge. So I'm just copy pasting it. Let's read the inputs. This is basically our initialize. Okay, rotating angle can only be minus 18 to 18. Okay, we'll handle that during our simulation. So we are going to simulate the future and then take decision based on that. We'll start with random search and then we'll change it to GA. We have to add this code here. Let's store all the checkpoints globally. So instead of having two variables, let's have an array of points. There are let's have a 20 for safety, and we can have a variable called checkpoints count. this is our current car's location, right? So I think we need to have a class called car. You don't need a player class here. So we have a point class, and going to create a class for a car. Car has a position, car has a velocity. What else do we get in input? We get the angle, but do we really need that right now? Not really, right? We can get the angle based on the velocity, so I think velocity is more than enough to work with. Yeah, that's right. Angle we don't really need. We just angles basically taken from the velocity only. Velocity gives the direction of the car. No, you don't need angle. Just need position and velocity. So what other inputs do we get? Get the position, velocity, checkpoint, right? So we need the information of checkpoint as well. So instead of having the only the current checkpoint, let's have something like checkpoints crossed. This will be really useful for us to when we do an evaluation based on the number of checkpoints we have crossed. So we will try to maximize the number of checkpoints crossed when we are evaluating the future. So that's why we are having this. Let's create a constructor. My algo got, I go to next checkpoint when it looks my car can pass this checkpoint and make thrust equal to 0 for drag. Okay, so basically reduce your speed when you already have enough speed to cross the checkpoint. But how ahead are you predicting it? Like, do you predict it one turn earlier, or how many turns earlier? Each turn going to a depth of 5. Okay, so you basically predict if you at in the next 5 turns can you reach the checkpoint. So in this case you reduce the speed to 0. So that's your logic, right? Okay. Did you refer the referee GRK? So I'm yet to refer the referee yet. Here is the referee code. Which you will be using for simulation. Okay, we'll come back to this. So in our game state, we'll have our current car. That's it. What rank are you in, Jerky? You're at rank 33. That's nice, really nice. You're done with initialization of checkpoints. Then you need to read the input for a particular turn. We need to find the checkpoints crossed for this particular car. That would be this, right? So current checkpoint, so at the first turn we get the checkpoint index as 0, right? Okay. I just need to check something. So if we do a -1 mod 5, do I get 4? I get -1, so this is a problem. So what we'll do is checkpoint crossed is the next checkpoint index -1 plus checkpoints count to the modulus checkpoints count. So now this should give the number of checkpoints that we have already crossed. So initially checkpoint index would be 1, so it would be 0. 0 minus 1 is -1 plus checkpoints count will be checkpoints count -1, so we'll get the last checkpoint at the first turn, which means which is actually wrong. We don't need the last checkpoints ID. We need the number of laps that we crossed as well to use this. Okay, actually that can be taken from the index itself, right? So we basically have all the checkpoints that's needed. So initially we'll be at 0 checkpoints crossed. I think it's just the checkpoint index that should give the number of checkpoints crossed. You don't have to complicate anything. Just get all the inputs, and we just don't need the angle. That's it. So now we need to start simulating. So in our end turn, we need to print basically the speed and the position, target and the speed. So let's go to our move class. So usually the experts would print rotation angle, thrust and the message. Let's try that out. So instead of printing the target position, we can print the angle that we need to rotate, and we can print the thrust that we need to speed. So our move is basically an angle and a thrust, right? And angle. It should be integer or it can be floats as well. I'm assuming this should be integers. Yeah. So this checkpoint index confused me a little bit, but it's pretty clear. So the checkpoint index gives away how many checkpoints we have crossed. So that's why they have duplicated the checkpoints as well. So initially, even if we have 3 checkpoints, they'll give 9 checkpoints. So the index gives the number of checkpoints that we have already crossed. And solution will have multiple moves. So for every depth, we'll have a move basically. So if I have a depth of say 10, then I'll have 10 moves. So right now I'll keep it as maybe a depth of 2. We'll increase it later. So each of these simulation will have a score. So my solution is a set of moves that I'm predicting to be done in the next moves, and what is the corresponding score for the set of moves. That's it. Now let's try to implement this. So what is the time for a specific turn? Is it 50 milliseconds? Okay, it's 50 milliseconds.
के बुखार, खांसी और सांस फूल अपने आप को इन तीन लक्षणों में बांट लीजिए। केवल बुखार है तो कोरोना के
So I need to get a random solution, right?
के लिए में रुके
So right now let's have
फॉर्मल
our
पैरासिटामोल की गोली आप खा सकते
custom thrusts array. So
हैं और कोशिश करिए कि लोगों
we'll
से ज़्यादा
try
ना मिलें
3 different
एक मीटर का
speeds,
जो डिस्टेंस
which is
बुखार और खांसी के लिए भी
You
यही
can
चीज़ है,
try
लेकिन हाँ, जब
0,
भी खांसी आती
100,
है
200.
तो आपको एक अगर आप मास्क
Let's
लगा
call it
सकते हैं
speed.
तो बहुत अच्छा रहेगा, और जिससे कि आप भी प्रोटेक्टेड रहें और आप
And
दूसरों के लिए भी।
our custom angles would be
कि हम ये बात नहीं कर रहे हैं कि कोरोना है,
minus
लेकिन
18,
अगर आपको बुखार, खांसी और आपका
0 and
सांस
18.
फूल रहा है
So we'll
तो
only
ये
try
थोड़ा
these
चिंता का
angles.
विषय हो सकता है। इसके लिए
We'll go to a
हमारे
depth
लिए
of 5 and see
कोविन
which is the best
हेल्पलाइन
decision that we
नंबर
need
था
to take.
1075। आप वहाँ फ़ोन करें, अपनी तबीयत के बारे में, अपने लक्षणों के बारे में उनसे ज़िक्र करें, उनको बताएं, और वो आपकी तुरंत मदद करेंगे। वो या तो आपके लिए एम्बुलेंस या जो भी सेवाएं होंगी तुरंत उपलब्ध कराएं। आपको स्वयं अस्पताल उसी वक्त जाने की आवश्यकता।
So we need the depth to be passed to this function as well. Or okay, we can do until each depth. So we need a random angle, right? What do you have for speed? It's thrust. I have to change it to speed. Let's finish our internals also. So we need to print solution dot moves of 0 at angle, right? Expert space angle and the speed. So you get a random angle and a random speed for all the depths. Now we need a function to simulate this turn. Just have to do play turn of this particular solution under depth, right? Just need to implement this function. Yeah, sure. I'll check the referee. think okay, should be good. So in the referee, what happens is, so on every round gets the outputs, which is our output. Just 1 second. Handle input, uncheck collisions. These three are the functions that we need to look into. We have the angle, target and message. Okay, if it is an expert rule, it gets the input. Need to do handle expert input. Yeah, so let's copy this code. So what is this 2 degrees? I think it's converting it to radian, converting the angle into radians, I guess. So it takes the current angle plus the new angle. So do I really need my current angle? Oh, nice. What does math.2 degrees do? It converted 45 into 2578.31. Okay, usually once we convert to radians, we can use any trigonometry calculations like cos, sine. So that's what it does. Let's find the C++ equivalent. I think it should be 2 radians, right? Okay, it's converting the current angle into degrees. So if we store the current angle in radians, this is not needed, right? So let's do that. So in the referee's game state, car has an angle and a previous angle as well. So where are they using the previous angle? Let's add it later, but for now let's add the angle. This is okay. This angle is different from this angle, right? So after start turn, what we'll do is we'll compute the current angle and store it. So angle of a vector. Just have to apply cos inverse. So I'll take the angle calculation from CSB that we have already used. Need to implement the distance function. Yeah. So this should be square root of the distance 2. For pi we can use m underscore pi. Why is m pi not being recognized? It's in CMath, right? M pi is non-standard. Is it? We'll just take the pi value from Wikipedia. I just want it to be as accurate as possible. Yeah. (180 by pi). Yeah, but I need the value of pi, so pre-calculate 180 by pi. That's too much. It's not really so important. Okay, this function basically finds the angle of any given vector. So this is exactly what we need to use in our start turn. So once we get the angle, our car's angle would be the angle of car's vector, car's velocity. It should be okay. This is the angle between two vectors. 1 second. Yeah, my bad. So this is the angle between vectors. So I need to find the angle with the origin, right? So origin is 0 0. So my angle should be origins angle from origin to the car's velocity. But then again, the angle is from 360, 0 to 360, which we need to convert to minus 180 to 180. What is this angle actually? This is my current angle. So I need to pass my current angle as well. I think it's better to move this function inside the car. This is the angle from my car to a particular point, particular vector. Angle from my car to a particular vector. So my new angle should be current angle plus the new angle. New angle should be solution moves of depth at angle. Storing the angle in the radians, but that's not so comfortable for us, so we will use actual angle instead of radians. Don't need this. Thrust towards the heading. So let's see what this does in the referee. So it basically computes the new velocity vector after the thrust. We'll just replace the code here. Before this, we need to convert it to radians. Okay, that's just 180 by pi, right? Multiplied by so 180 by pi is to convert radians into degrees. So we need to multiply by pi by 180. This would basically be my new core angle, right? Let's use floats. Floats should be a little bit slightly faster than double because the number of bits is very less for floats. So let's stick to floats. We need to update the velocity. Change my points to floats. It's all integers right now. So after handle expert input, where is the position getting updated? That's what I'm interested in. So it should update the position of the car, right? So it takes the input from us and computes the new angle, computes the new velocity. Where is it doing the new position calculation? Okay, it's done in here itself. Is it? No, it's not done. They probably do it after handle input. Yeah, so checks for collision and after that only the car adjusts. So adjust is basically should that's a super dot adjust. So what's the base class of car? It's called unit. Okay. Okay, here they just truncate and update the friction. I think we can use the same function. This for a particular unit, right? So you can use this in our car class also. Isn't truncate is equivalent to floor, right? So what does utility.truncate do? Where does this utility come from? There is a class called utility. What? So many classes. So they do a rounding function here. Let's use the same. So it converts a double into integer. That's it. So we don't have to necessarily replicate this. That's what they have mentioned. So we'll just use so what they are doing is, in this case, they are rounding it down. So we can simply use the round in C++. That should do. Cats. So what's the friction in the problem? Friction is 0.85.
मुझ में तुम समाए हो, मैं हूँ अगर काया तो तुम
Let's
मेरी
check it out.
परछाई हो राधे। क्यों भला घड़ी विरह की आज है आई,
It's in core friction constants. It's 0.15. Yeah, that's what I thought. So this is 0.85. This means this entire part is, I mean, this is 0.15, this should be 0.85, right?
Krishna 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 Radha 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 Krishna 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 Radha
So this
Radha Krishna Radha Krishna 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 Radha Krishna.
I know why they are converting this integer back into another double and then checking epsilon. Maybe there is some issue in Java rounding or something, so they are doing this. So in C++ we don't have to do this.
जग की है
once we adjust this, we have to change the degrees, change angle.
ये कोरोना वायरस जो भी है लेकिन बहुत गलत चीज़ है ये चीज़ बच्चों को अपने आप सेफ रखना है और चेहरे पे मास्क लगा के घूमना है और तो
We
कोई
have to
खांस
do
रहा हो
this.
छींक रहा हो उससे थोड़ा मतलब थोड़ा 10 मिनट की थोड़ी दूरी पे रहो इस चीज़ से बचाव बचाव करके मतलब अपनी सेफ्टी खुद
So
रखो
they are just
अभी
checking.
चिकन मीट मच्छी कोई चीज़ खाना नहीं चाहिए
They're converting to 0 to 360 so that this angles do not get messed up.
जो हो रखा है उससे फैल रहा है साफ सफाई रखना चाहिए हाथ मुंह में मास्क लगा कर रखना चाहिए भीड़ में नहीं घूमना चाहिए ठंडी चीज नहीं खाना चाहिए
So before this, in the check collisions, I think they probably check the checkpoints.
उसमें तो 20 सेकंड तक कम से कम हाथ धोना चाहिए साबुन से
This can
उसके बाद
be
मास्क
straightforward.
लगा के रखना चाहिए 1 या 2 मीटर की दूरी भी रखनी चाहिए हाथ न मिलाएं और चिकन अंडा ना खाएं उससे ज़्यादा होता है हो सकता है उससे ज़्यादा होता है
So you can handle differently. So what does this game has? Okay, nothing. So this is the execute function. Where are they updating the position is what I'm confused about. In the car class, they're not updating the position anywhere. Okay, there is a move function in the collision, so this part does the movement. So we can use that for now. This is the move function. It should be in the base class, I guess, which is unit class. Just this. Should we speed into thrust, right? So go to point class. need to implement multiplication operator by thrust. Okay, this doesn't seem to work. So when should we call the adjust? After handle input and after the collisions. Which means after our move we need to call the adjust. That's it. And once we adjust, you will check if we have crossed the checkpoint. So if car's position is inside any checkpoint. So wait, what is this sound? It's just talking. Okay. You just need to check the collision, right? So here, car's distance to the checkpoint. So my next checkpoint would be this, right? So point, next checkpoint would be checkpoints of I plus 1. Points of current checkpoint, which is car dot checkpoints crossed +1. I'll just have something like this. Next checkpoint index. So suppose if this is, so after our last turn, after completing all the laps, so if this checkpoint goes greater than checkpoints count, then my next checkpoint would be again 0. Or what I will do is at start turn or at initialize, what I can do is after reaching the checkpoint I don't have to go anywhere, so I'll just add until my next depth. Skip 30 for safety. It's okay, you can keep something like 50, 60, fine. Checkpoints of the last checkpoint. Then we'll increase the checkpoints count to depth. This ensures that my code doesn't crashes after reaching a last checkpoint. So on my play turn, my next checkpoint index is always checkpoints of my current checkpoint index, which is cars checkpoint cross +1. Now this doesn't crashes even if I reach the last checkpoint. This code doesn't crash. So suppose if this is less than, this is 600 square, right? This means I am already inside a checkpoint. So my next checkpoint should update. That's it. Now we have done the full simulation. Now we just need a scoring function. We'll compute the score for this particular game state. So currently you don't need this. Okay. We need the score to be stored in the solution, so we need to pass the solution. Initially the score to 0, and my score is based on the distance to next checkpoint, right? It should be minimal, so my score is my car dot HS cars positions distance to the next checkpoint. So this is the next checkpoint, right? This should be minimal. That's it. So once we get the solution for this particular simulation, and if the score is greater than our best solution that we have computed so far, now just clone this solution into the best solution. That's it. This should get us the best move. Simulate, get the score. So let's try a depth of 1 first and see what happens. Let's see if this compiles. All good. So after our play turn, we adjust. Actually, we adjust after the collisions, right? So let's do adjust here. Finally, in our end turn, we have to print the angle and the speed. Oh, my bad. Why does it take so long? Okay, so my bot never moved. My bot keeps circulating here. Let's see what's happening. So we are getting 9 checkpoints. Is there a leading zero? Leading space? Okay, this shouldn't be here. So we get all the checkpoints. I'm printing 0 high. So I'm printing an angle of 0 and a thrust of 0. So my thrust is always at 0. So this is probably because I'm trying to stay inside the same checkpoint. So it's probably calculating score for staying inside my checkpoint and doesn't want to move. So let's check my play turn. My next checkpoint is checkpoints crossed +1. So my start turn, I'm reading the checkpoints crossed, which is initially 0. So our next checkpoint would be 1. So we need to minimize the distance to checkpoint 1, number 1. Right? So let's just print after our play turn, let's just print what's happening. Or we can debug this locally as well. This is our input for the 0th turn.
कोरोना वायरस का जहां तक तल्लक है, किसी भी किस्म की कोई ऐसी डाइट नहीं है जो कि कोरोना वायरस से हमारा बचाव कर दे या उसकी ट्रीटमेंट। लेकिन हाँ, क्योंकि कोरोना वायरस की इन्फेक्शन फैल सकती है, तो हमें अपने शरीर
Let's
को
try some
सुरक्षित
100
रखना है।
simulations
तो हमारे को
locally, see
पौष्टिक
what's
आहार जो
happening.
भी है बच्चों को देना है, हाई प्रोटीन डाइट देनी है, हरी सब्जियां भी देनी है,
Let's keep a
उनको वाइटमिन
breakpoint in
युक्त
here.
हमने सारा खाना।
So we got a random solution. Let's see what's in this solution. So we should have one move. We have an angle 18 and a speed 200. Okay. Now I'll be going inside play turn. So my current course angle, let's see the course angle. So my current course angle is something bad, so which I need to fix. So in my start turn, I need to compute the right angle for my car. So this probably didn't work as expected. So let's have a breakpoint here and see what's happening. My car's velocity is 0, 0, which is right. So this is the issue. So if my car doesn't move, then how do we compute an angle? Your total code size is 54 lines. Okay, so our car's velocity is 0 and we need to find the angle of our car. Let's see what's in this angle variable. So it says 161. Can we use that? So that's the actual angle that we use in that's the angle from the origin. Which is what we need as well, right? Let's take the input as course angle. See what happens. current course angle is 161. If I get inside the plate turn, my new angle would be 179. And my velocity has changed. My course position has also changed. But this is 29,640. Really, we have so many points. We'll come back at this. So we started here. So currently my course position is this. Compute the new angle. Now my velocity difference is minus 199 and 3. This is probably because of my speed, right? So my speed is split into x-axis and y-axis. This is the new velocity difference that I am adding to the current velocity. So this new vector becomes my current velocity. You can see that my velocity has changed here. But I need to apply the friction, right? I need to apply the friction to this velocity. I've done 0.85 somewhere. So which is here in the adjust. So this is after our particular move. Our velocity will get adjusted like this. So but here it should update just like this, right? So my new core position would be this. Here I shouldn't multiply the speed. This is the problem I'm doing. So what did I do mistakenly here? There was a variable called t here. Which is velocity into thrust, right? Okay, probably we have a unit vector here, but we don't need that here, so we just need this. Well, let's see if this works. My logic's base is from the referee. So basically I'm simulating based on the referee code. Where is our car? Is my car heading towards 2 and not 1? Because we have a depth of 1. Let's try a depth of 5. See if we are predicting 5 steps ahead. There you go. My bot is tumbling, but this looks better, right? So we started at 0. We reached 1. We didn't go to 2, right? Instead of going to 2, we went to 0. Okay, if I predict the next 5 turns, then it's assuming I need to go to 0 instead of going to 2. So that is the problem here. So instead of increasing the next checkpoint in my play turn, so let's just comment this code out right now. So that our scoring is correct. So if we do this in our simulation, this part in our simulation, then we need to add a score for the number of checkpoints crossed. So we will add that later. For now, let's keep it simple. So our scoring function is simply the distance to the next checkpoint. I'm going to 2 instead of 1. Really? So let's debug this. So let's see, after my play turn, my next checkpoint should still be what's the issue here? No space left on device. Okay, so now what's our course checkpoint crossed? 0, right? So now when I get inside the get score, I shouldn't do +1. Again forgot. So this is basically the next checkpoint. Just change this back. Now try this. $105 turns. This looks awesome. Our simulation has worked. So right now we are doing a depth of 5, right? So to improve this, so we need to revert this change where so let's submit the solution first. We should drastically improve our rank right now. Okay, we got a score of 16,000, which is amazing. So we are already on probably top 30, right? That's amazing. Our first version has got into a top 30 rank. Oh no, my recorder took all the space. So today's date is 30, right? I'll delete the old streams. That should free up some space on my disk. So right now we are going to a depth of 5. rotating after reaching first. Yeah, that's what I'm doing, which I need to fix right now. So I'll just show you how my current bot works. This is still good, right? So we are breaking ahead. So we are not turning ahead, but we are only breaking ahead. So our next thing would be to add the turning ahead part. My rank is updated or not? Yeah, I'm at rank 29 right now. So our score is a single line score, which we need to change. Now I'm going to change it to based on the number of checkpoints. I'm going to give a score. Let's give a huge score for this. So currently I think my score is an integer as well. We need to change that to float for this to be accurate. Let's use distance here instead of distance square. That's it. So in our play turn, this is our entire simulation in just 4 lines of code. So this part we need to revert back. So this is my next checkpoint, and if I'm crossed the checkpoint, then my checkpoints count will get increased. So this change will turn ahead of the turn. So right now I got 312 on this test 7, right? Now this should be better. This bot should perform better. Yeah, we got in like 60 turns better, so we are now dragging so nicely. So here we are doing so amazing. We are drifting like crazy, Tokyo drift. See how many simulations we are getting. We easily get 87,000 simulations. So I think we can increase our depth. Our current depth is only 5. So let's increase our depth further. Like, let's give some crazy depth of 20. See what happens. So currently it's 197 turns. Okay, sorry, it's still 242 turns. Okay, it's 242 turns. Now let's see if this improves. Okay, this has worsened our bot a bit. This is also probably because our random will not work properly at higher depth. So if we run mutations on top of this could dominate. So I think let's try mutation. We have enough simulations, so let's add mutation to this.
Play them now in the YouTube Music app.
So mutation is just like we modify the particular gene slightly. So our gene is nothing but a random solution, right? So we have found a random solution here using our random search. So instead of doing it for 45 milliseconds, I'll just do it for 25 milliseconds. And for the rest of 20 milliseconds, I will do something else. So after this ends, so I'll again start the timer for 20 milliseconds. So that I will use totally 45 milliseconds in total. This is for our mutations. So we already have a solution, so we just have to mutate our current solution. So let's create a function for this. So before this, I think we can submit our bot with a depth of say 5. We'll submit this. This should take us to at least top 25 or something. We are currently ranked 29, so this should be, or even top 20. Let's see. Yeah, this is so nice. We got a 15,000 score. We failed on test 7 and test 27. Why did we fail on test 7? This is not test 7. Test 7 is still in progress. Yeah. We finished this, right? But why does it say we failed this test? Is it possible to see this? We failed on 3 tests. How do we debug those? So without going 100%, our score will not update, is it? Did our code crash or exit time limit? It's random, sometimes fails. Really? So locally all my tests are running fine so far. Fails because of no failure means we haven't completed 3 loops, right? That's so. Does it mean we haven't completed 3 loops in 600 turns? I'll just resubmit and see. Okay, then we should get the same score, right? Now we get 92%. So the maps are probably random. But how do we debug those maps? Are the maps like so crazy that do we have to pause all the cases to get into the leaderboard? That's fine, even if I don't complete in 600 turns. It should give me some score, right? I should get into leaderboard, right? My new score is not even in the leaderboard. Oh really? So
कोरोना वायरस का जहां तक तल्लक है, किसी भी
score
किस्म
is
की कोई
first
ऐसी
based
डाइट नहीं
on
है
the
जो कि कोरोना वायरस से
percentage, is
हमारा
it?
बचाव कर दे या उसकी ट्रीटमेंट।
Oh,
लेकिन हाँ,
first they take
क्योंकि
all the
कोरोना वायरस की
100%
इन्फेक्शन
and then
फैल
they
सकती
sort
है,
by.
तो हमें अपने शरीर को शक्तिशाली रखना है। तो हमारे को
Got
पौष्टिक
it.
आहार जो भी
So
है बच्चों को
we
देना है, हाई
our
प्रोटीन
non
डाइट देनी है,
100%
हरी
solution would
सब्जियां भी
be
देनी है,
bad.
उनको विटामिन युक्त हमने सारा खान पान देना है, तो उनको हेल्दी रखना है। तो एक जनरल हेल्थ के लिए जो भी हम ध्यान रखते हैं, साफ सफाई का ध्यान रखते हैं, हैंड हाइजीन
So
का
I
ध्यान
think
रखते हैं, रेस्पिरेटरी हाइजीन का ध्यान रखते हैं,
what might have
खाने पीने
changed?
में जिस तरह से भी हम बच्चों को एक पौष्टिक
Not
आहार
so
देते
sure.
हैं, वो हमारे को देना चाहिए। और यहाँ पे ये भी बता दूं कि किसी किस्म का चिकन
Okay,
है,
let's try
अंडे
mutate
हैं,
and
जिस तरह
see
तरह की भ्रांतियां हैं कि अंडा
how
खाने से
this
बीमारी हो
improves
जाएगी,
our
चिकन
what.
खाने से हो जाएगी, बिल्कुल नहीं होगी। किसी समय में ये
So given a solution, it will mutate it. That's it. So now what we do at this step is we slightly change the angle or the speed. So we'll take random position in the random depth in this. And we can either modify the angle or the speed. So can have a this will be, we can have a probability of 10%. So rand mod 10 becomes 0, the probability is 10%. So 10% of the times I have to update the angle. Same way, 10% of the times I will update the speed. So this is what we do in mutation. So once we mutate our solution, we'll again play this entire game and see if this new solution gives a better score. That's it. So let's see how many mutation sims that we get. So here we shouldn't mutate the temporary solution. We have to mutate our best solution, right? So let's take our best solution and clone it to our temporary solution. And then mutate the temporary solution and check if this is better. That's nice, GRK. So we have increased our depth to 20. What happened? Will it time out, is it? Our code doesn't compile. This looks good, right? Let's try some complicated case. 19 got failed earlier. So with mutate, let's see if this passes. Otherwise, we'll reduce the depth. Reducing depth should resolve the issue actually. Yeah, 20 is I think too high. Let's reduce our depth to probably let's keep 5 again. Let's see if all cases passes first. Cool. But you still have a braking strategy. It looks like you are turning earlier, but not too earlier. So you need to turn a little bit earlier. So see, if you see my replay now, you can see like, so yours was like 117 turns. Was this for? So in test 1, I'll just stop all. So here you can see in my replay, sorry, this is your replay. Yeah. See, I have done it in 88 turns. In your replay, it was 117 turns, right? So I was able to do it in 88 turns because I have a mutation as well and I turn really early. So now let's submit this and see if this improves. We still got 94% only. We really need the full score. Let's just decrease our depth further. Say depth of 3. We had a 100% score with braking strategy, but when we changed it to next checkpoint movement, then our score got decreased. Okay, this looks too bad with depth 3. So maybe I need to go somewhere in the middle from 5 to, so instead of going till a depth of 5. Let's go till a depth of 10. See what happens. I think our bot should still do good. The depth of 10. Now it's 96 turns. Depth of 10 is sometimes bad, but it's something. We got a 100% score again. Is it? What's the score? Results should give me right 98%. Only one test case has failed. Okay, but we need to find somewhere in the middle still. Like 10 is still too high. Maybe 8 should do good. What depth do you have, JRK? Still 5 depth? Depth 8 looks somewhat smooth. Wow, this is we got a 100% score at 14,000. This is really nice. So we probably end up in top 20. That's amazing. We reached top 20 in our stream. I think this is good enough for the stream today. I'll again stream in the evening, probably paper soccer. So that will be around 7 p.m. 7 or 8 p.m. IST. So I hope you guys all join. Yeah, my rank has become 22. $22 is not bad at all. He gave a new replay. Let's check that. Or is this still the old replay? It's still the old replay. Use less time, 35 milliseconds. Players had random timeouts when using greater than 40. Oh. Is it? Okay, so now with 45 milliseconds I got this. It's working for me. So it's probably random as you said. So I don't want to ruin my score right now at the end of the stream. I feel top 20 is good for the stream. Thank you Illidon for the game. It was fun. And your referee really helped. So if you look my code, like the referee is like 10 lines of code. These are the 10 lines of code that I did to replicate the referee. So simple. And I didn't use your collision code actually. I used my own collision code. So my code will not work for crossing two checkpoints on the same turn. So I probably I will slow down, right? So I think I can fix that easily right now. Just let me check. Did it change any code right now? I didn't change anything. So now let me fix that. So it's okay to cross 2 checkpoints in a particular turn. So to make this change, so I'll move half step at a time instead of moving full steps. Just do, say, half step at a time. So just copy this, replicate here, and I reduce this move vector to half the size. So I'll move half the step first and see if I have crossed any checkpoint at this half, and same I do at the other half. I think this should resolve that. This is like a hack, but this should work. Okay, I have an error here. Reinitialize the same variable. Our test one failed. No, it's, yeah, our test one got failed. What's wrong? Okay, maybe it's surprising actually. I move towards this direction, but to reduce the length of this, so I'll just comment this code back. We'll add this later and revert this to full turn. I'll show you how many sims I get. So this is my current bot, and I easily get like 35,000 sims easily. Yeah, it's 35,000 to 40,000 sims. And right now I'm trying to do cross 2 checkpoints in a single turn, so that's not working for me properly. Okay, let's end the stream here. I can fix that later. You can also fix that later. So let's see some complicated map. This is the longest map, right? Let's try that. This is the kind of map where we can go really fast to cross 2 checkpoints in a single turn. Because 0, 1, 2 and 3 are all in the straight line, right? So from here, so as you can see in the first lap, no, replay got changed. Yeah, anyway, you get the idea. Thank you all for joining the stream. Immortal, did you submit in search race? Haven't. You should really try it out, check it out. This is really fun. I think if we add neural networks, we can easily get to the state. So what I mean by neural networks is we have to plot these results in a graph. Say for the given state, we always print the angle and the thrust, right? So just plot these as a graph. You will get a pattern, create a formula with the pattern, and then use that formula to print the best solution. That will be very accurate. This is like a zigzag map. Thank you everyone.
Getting COVID disease. कैसे बचे?